All right, welcome back. So we've got another problem to solve. Remember that programming is all about taking this giant problem and breaking it into smaller problems and approaching those one at a time. Our current smaller problem is that I need to place 10 bombs or whatever number of bombs throughout my throughout these nodes. I need to have 10 bombs there or whatever. We need to be able to adjust that though as well. So let's create a new variable called bomb count, which is essentially going to be the number of bombs. We'll set it to 10 for now, just for testing, and then we'll see if we like that, if we want more, if we want less. So let bomb count equal 10. And then I want to track which indices need to be flipped over to that 10. So this isn't going to make a lot of sense yet, but it will make sense, I promise. This is going to be a number array. So let's just explicitly state it that way so that we don't have any issues. And now I need to generate a list of 10 values between 0 and how many total nodes we have, essentially. And that's going to be the ones that end up being bombs. Those values all have to be unique, though. So the way we're going to do this is, let's create a new function down here called function generate bombs, maybe works for me. So the total number of nodes we have is rows times calls, right? So the number of rows we have times the number of columns we have is the total number of nodes we have, which is 100. So I want that to be my min value and my max value. So I need a random value between those two. So rand int 0 and rows times calls. However, rows times calls is going to give me 100, and I don't want to include 100, so I have to reduce this by 1 so that it's 99 instead of 100. We've done this -1 a lot of times. A lot of times new programmers forget about that. You have to decide whether you actually need that or not, and that can depend on if the function is inclusive. So if the max is included, you often will need that -1, because 0 to 100 is actually 101 values, and we only want 100 values. Anyway, we've got our random int here, so we're selecting a random int, but what we need to do is we have, what's it called, bombs? Okay. So we're going to have a while loop here. While bombs.length is less than the bomb count. So essentially I need this bombs to have a total of 10 values in here. And then that will be enough bombs. So while it's less than bomb count, keep repeating this over and over and over again until we get to that 10. So the first thing we're going to do is we'll have a let random index equal rand int here, and then we need to check to see if this exists inside of our bombs array. And Python has a really smooth way of doing this. I think JavaScript, how do we do that? Index of, I think. Let's see if this, I believe this works. So what it is bombs, if bombs.index of, yes. Okay, so index of basically will give us the index of a value. So basically that means that if the value exists in there, it'll tell us where it exists. So let's say we have an array with like 1, 5, and 8, and then I put, index of 5. Well, it'll find where that 5 exists, and since it's the second value, it'll return 1, 0 and then 1. It'll return 1. However, if it doesn't exist in the array at all, then it will give us -1, and that's actually what we want. So this logic right here, index of random index, this will tell us whether it already exists or not, because we don't want the same value ever in our bombs, because we want 10 unique bombs. So if it doesn't exist, essentially this is kind of sloppy, but it's saying if it doesn't exist. If this doesn't exist in our bombs array, then add it to the bombs array. Bombs.push random index. So now I should end up with always with 10 bombs in here. Like that. Okay. okay. Let me clear this index out. I was doing a little bit of testing. I didn't quite have it right, but I think this is correct now. So now let's call generate bombs here, generate bombs. And let's see if it does it correctly. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hey, and no repeats. Do it again. No repeats. Very cool. Hey, the first one was 0. What are the odds of that? 1 in 100. Okay, so I'm always getting 10, and they're always randomized, and I never see any duplicates. So I believe it's doing what we want it to do, and that's great. Now, how do I actually apply these to our grid here? Well, when we're generating our grid, our nodes, remember that this is the value for bomb right here. Has bomb Boolean. So right now I'm setting them to false, which means none of them have bombs. But what I want to do is the same thing that I do here, I believe, where I'm going to be checking if that exists. So it's actually going to be the same exact logic here. So I'm going to grab this out, this entire thing out, and we're going to put that, right here. And then index of random index. Instead of this, it's going to be, how do we do this? We need a counter, essentially. Let counter equals 0. And then here we're going to increment the counter as we go through. Counter plus plus. Basically, because we have our rows and columns, the counter is going to increment one at a time here. And this is going to start at 0. When we check here, it's going to be 0 the first time. And then it's going to be 1, 2, 3, 4. And it's going to keep going up. So we're going to check to see if our counter value is in here. And if it is, then we want this one to be true. Otherwise, we want it to be false. So let's, by default, this is if it doesn't exist. So we're going to say let has bomb be true. And then if it doesn't exist in there, we're going to set it back to false. And then here we're going to put has bomb. Now, so we're counting from 0 to 99. And each of those values, we're going to default to say that that bomb is true. And then we're going to check to see if it exists in that index. And if it doesn't exist, then we go, okay, actually it doesn't have a bomb. So we're going to assume that they all have bombs until we prove differently. The reason we're doing it that way instead of the other way around, it's just a lot easier. Well, we could flip it, but we just say does not equal 1 instead of does equal, or does not equal -1 instead of does equal -1. Doesn't really matter the order we do it in. The key thing is that we need to have one outside and then we need to change it inside, because we want to, if we try to use it here, then it needs to be scoped outside of this if statement. All right, so let's see what this does for us. Let's see if, look at that, we're getting numbers here. So that means that one of these is a bomb around here. There it is, we found a bomb. And around 2, there should be another bomb somewhere. So 2, 1 here and 1 here. So these 3 should not have bombs. There should be no bombs here. And yeah, all of these are 0, so there's a bomb here somewhere. Very cool. There's one more little thing that we need to do. Well, there's a few more little things we need to do. The big one is when we hit a square that has no bombs around the outside, we also need to reveal all adjacent squares. So if the bomb count is 0, we want to reveal everything around the outside, which we'll do.